In this video, we are going to be looking at probability. Now, probability is just the likelihood of an event occurring. Now, the best way I can explain this is if we look at rolling a die. You know a die now. When we roll a die, we can have either 1 appearing, 2 appearing, 3 appearing, 4 appearing, 5 appearing, or 6 appearing. So in this case, we've got like 6 various events occurring. Now I can now ask myself, what is the likelihood that if I roll a fair die, 1 will appear on top? What's the probability of that happening? What's the likelihood of that happening? Does that make sense to you? Now, for probability of an event, we've got a scale. Now we have 2 extremes. On this side we've got 0, on this side we've got 1. Can you see? So it then means that the probability of an event occurring cannot be more than 1, and the probability of an event occurring cannot be less than 0. So if someone told you that the probability of an event occurring is 1.5, this is totally wrong. It's not possible. And if someone told you that the probability of an event occurring is minus 0.7, it's wrong. It's not possible. And that's because 1.5 is greater than 1 and minus 0.7 is less than 0. Does that make sense? Now, what does this symbolize? Now, 0 on this side, on the left hand side, symbolizes impossibility. Does that make sense? And then 1 symbolizes certainty. Now, if I ask you, we've got a pregnant woman. Now, if I ask you, what's the probability that if this woman is delivered of a baby, the baby will be half boy and half girl? Now, naturally speaking, this is impossible. So the probability of this event occurring is 0. Does that make sense? Now, if I ask you, what's the probability that next week we are going to have 7 days? Now, that's a certainty. We have 7 days in every week. So the probability of having 7 days next week is 1 because it's a certainty. Next week we are going to have 7 days. Does this make sense? So the probability of any other event happening can be within these 2 extremes. So we can have 0.7, we can have the probability of another event occurring to be 0.5. The probability of another event occurring can be 0.95. It can be anything within these 2 extremes. Do you understand? Now, the next thing we want to touch on is the formula for probability. What's the formula for probability? So we've got probability equals to number of required occurrence all over number of possible occurrence. Now, this is the formula for probability. Number of required occurrence all over number of possible occurrence. Does this make sense? Now, to be able to understand how to use this formula, let's take some examples. So we've got the question: a bag contains 5 red balls, 12 blue balls, and 7 yellow balls. If a ball is picked random, what's the probability that A, it's a blue ball, B, it's a red ball, C, it's a yellow ball? Now let's solve this. So remember, the first thing you want to write is the formula. So the formula for probability equals to number of required outcome all over number of possible outcome. Now from the question, we were told that we've got 5 red balls, so red balls equals to 5. We've got 12 blue balls, and then we've got 7 yellow balls. Does this make sense? It means that the total number of balls is 5 plus 12 plus 7. That means the total number of balls, 5 plus 12 is 17. 17 plus 7 will give us 24. So let's take question A. What's the probability of picking a blue ball? Now we've got number of required outcome. How many blue balls do we have? 12. All over number of possible outcomes. What's the total number of balls? We have 24. Can you see? So we'll be having 12 here 1. 12 in 24 is 2. So probability of picking a blue ball is 1 over 2. And if you turn 1 over 2 to decimal, you'll be having 0.5, which is within the limits. Does that make sense? Now B, what's the probability of picking a red ball? So probability of picking a red ball. How many red balls do we have? We have 5 red balls, so we have 5 over, what's the total number of balls? 24. So probability of picking a red ball is 5 over 24. Do you understand this? Then lastly, what's the probability of picking a yellow ball? Now probability of picking a yellow ball. How many yellow balls do we have? We have 7 yellow balls. What's the total number of balls? 24. Now remember, we said that the limits for probability of an event is 0 and 1. So the highest being 1. So what this means is that if you've got an event, if you add all the probabilities together, you should get 1. If you do not get 1, then you are not correct. For example, if we want to confirm our answers, all we need to do is to add 1 over 2 plus 5 over 24 plus 7 over 24. And that should give us 1. If it does not give us 1, then we are not correct. Does that make sense? We can try that. Let's try to do that somewhere here. So we have probability of picking a blue ball is 1 over 2. Probability of picking a red ball is 5 over 24. Probability of picking a yellow ball is 7 over 24. So this is just us trying to confirm our answers. So we've got LCM is 24. 24 divided by 2 is 12. 12 times 1 is 12. 24 divided by 24 is 1. 1 times 5 is 5. 24 divided by 24 is 1. 1 times 7 is 7. 12 plus 5 is 17. 17 plus 7 is 24. So we have 24 over 24. And 24 divided by 24 is 1. Can you see? So this just confirms that our answers are right. Does this make sense? So don't forget, probability is number of required outcome over number of possible outcome. So in a question like this, all you need to just do is how many blue balls do we have in the basket or in the bag or whatsoever, all over what's the total number of balls, or what's the total number of fruits, or what's the total number of whatsoever. Does that make sense? Let's take another question. So we've got this question. In a school of 250 students, 70 love math, 100 love English, while 80 students love geography. If a student is picked at random, what's the probability that she loves geography? Now let's solve this. Remember, the first thing, what's the formula for probability? We have probability equals to number of required outcome all over number of possible outcomes. Alright, now I should have noted in the previous question that, remember, we're told that a bar contains 5 red balls, 6 blue balls, etc. Normally, how I should have represented it is number of blue balls equals to 7, number of yellow balls equals to 12, something like that. It just makes things look easier. Does that make sense? Now, having said that, let's look at this question. Now, from the question, we're told that 70 students love maths. So if I represent it as number of students that love maths equals to 70, then I've got number of students that love English equals to how many? 100. So we've got 100. And then we have number of students that love geography equals to 80. Now, in this question, we're told that in a school of 250 students, so we've been given the total number of students in the school. So total number of students, we can represent that as T equals to 250. So we're asked, if a student is picked at random, what's the probability that she loves geography? So we have probability that she loves geography equals to, how many students love geography? We've got 80. So we have 80 all over. What's the total number of students in the class? 250. Do you understand? 0 cancels 0. It means that the probability that the student picked loves geography equals to 8 over 25. And this is our answer.